Hello, this is Pulp-IT here, and after quite a long break, I would like to come back with another movies from the Windows series. And today I would like to cover some Windows 2016 features related to the DHCP server. Of course, this will be also related to the previous version of Windows. We are going to divide this into two lessons. First will be a basic stuff like installing, configuring, post configuration process. We're going to talk about a little bit about DORA process and so on. And this will be quite a good entrance to much more complicated things, much more convoluted that we're going to cover in the second chapter. And then we are going to talk about clustering on the DHCP service. We are going to talk about and of course show also a native failover that is embedded in Windows 2012 and Windows 2016 DHCP service. And of course, we are going to talk about the backups. Uh, all of those stuff is quite important, quite common in bigger environments also. Um, but at first, we are going to show how to get this service working in a few basic steps. Okay, so I'm glad I can be here and glad to show you some really cool stuff. So let's go over with this and start the first lesson. Okay, at first I would like to show you an environment that we will be dealing with. Probably you already realized that I using now Windows 2016, and I switched back from my old Kali Linux because this is the first Windows server that actually have a feature called nested virtualization, which means that I can virtualize already virtualized environments. So virtual machines inside the virtual machines. It was quite common in other vendors, other manufacturers. It was already there in Oracle VirtualBox, for example. It was already there in Linux KVM and many other hypervisors. But it's the first time that Microsoft decided to use it in Windows 2016. Okay, so let's go ahead with a let's go to Hyper-V Manager here. I would like to show you what we got here, what environment we are dealing with. All right, let's get a moment. Okay. For our purposes, I prepared three Windows 2016 servers that we'll be configuring, and we are going to use all of them, especially in a later chapter that we will be dealing with the clustering, which two of those will be cluster nodes. One will be a resource node that will be delivering the resources to the cluster. And we have also Windows 7 machine here, and this Windows 7 will be dealing with as a client, and we are going to perform some basics check on it. These servers are part of a one virtual switch, so they're inside one local area network, you could say, and they've already had a basic connectivity. And so let's go at first to the command line here. Let's go ipconfig. Yeah, let's first a machine has a 51 IP address, last octet, and the other two have 52 and 53. So let's try to ping 192.168.0.52, for example. Yes, we got connectivity here, and 53. Yes, we have it. Okay, I've already also turned off the Windows firewall just for sake. If any problems could occur, sometimes well, firewall can do some crazy stuff that will not allow us to perform in troubleshooting. This can be awesome. So connectivity is already there. The first machine is also a domain controller because I would like to deploy the DHCP in a domain environment to show you that will need to authorize this DHCP services inside the domain domain environment to get this DHCP working. Okay, so let's go with our first configuration step. So we are going to install the service. Okay, I've picked a third server. We're going to deploy a DHCP service inside. Now this is completely empty service, so let's go ahead with this. Let's take a look what we've got here. Um, Administrative tools, okay. Yeah, as you can see, there is no MMC snap-ins here for DHCP, so we'll have to install it. And the most common, the most usual thing about Windows, if you're not using a core edition, that you can use GUI. So it's the easiest way to install the features. But you can of course use a PowerShell also, or dism command to install it. So because there is no service right now, so let's go to install it, and we're going to use a PowerShell this time. PowerShell to get this more complicated. Okay, so let's at first be sure that there is no DHCP installed. Get Windows feature. Come on, come on, come on, come on. Get Windows feature. Let's go with the name. Uh, name. It was a DHCP. Oh, come on. There should be a star. DHCP. Okay. Yeah, the install states is telling us that this feature is available, so it has a payload for installing this, but it's not installed right now. So we're going to install both the DHCP server and DHCP server tools. So we're going to get the following command: install Windows feature, okay, and followed by the name DHCP. We are going to include all sub features and include management tools. And that's all. I know that it's much easier to just click in the GUI, but it's better to know the PowerShell because in many environments you will have only core edition, and it's just more useful. Okay, let's wait for this to install, and we'll then try to post configure it. Alright, as you can see, it was successfully installed. We have a DHCP service right now. Let's go to the Windows Administrative Tools. Yes, and there is a DHCP snap in here. Of course, we will have to configure it right now because as you can see, there are drop down red arrows, so it needs an authorization. It means that the authorization and domain will be needed. So, but at first, let's go to the server manager. Okay, let's get a moment to load all those stuff up, and we've got here some exclamation mark. This exclamation mark tells us that we need to do some post deployment configuration. And if we click over here and go the next, well, let's at first talk about the first screen. Uh, it's going to create the two local groups for the DHCP administrator and DHCP users. The first thing about this is these are not domain-wide groups, they're only local groups. So, which means that if you have already DHCP in your Active Directory environment, you will not mess anything because it will be creating these groups only on the local machine, local new DHCP server. So don't worry about that. And the second screen is about the authorizing this DHCP server in Active Directory services. So we need to have this server authorized to allow him in Active Directory to issue an IP addresses to the clients. Sometimes, of course, it's also possible that somebody will do this for us on different way. What is a different way? Well, you can go here in a DHCP, snap in, go to manage authorized servers, and click authorize. After providing an IP address of this server, 192.168.0.53, and clicking OK, as we can see, the name has been already filled up, so it recognized this server, and we can just authorize it in a domain. Now the server is authorized inside the domain. Okay, so if we were going to refresh it, as you can see, we have a green arrow, so everything is okay. It can start servicing the client. But what about the server manager here? Let's go here once again. Okay, well, the exclamation mark is still here, so we will have to also create the local groups, right, to get this all things working together. So you can use it, of course, here GUI. So because we've already have an active directory authorized, we can skip the authorization and get it with the commit. But as you already know, there's a lot of ways to achieve the same goal in Windows machines. So you can use, for example, netsh command here to get those group created for you. Okay, so let's go with the command prompt here. Type netsh. Netsh is a very broad, very wide command that it's able to do a lot of stuff and a lot of things in different ways. It's, as you can see, it's RAS, for example. Here you can use it. You can use a trace, IPsec, a lot of stuff. But one of the sub commands here is DHCP to get the DHCP server configured. And as you can see, uh, there are plenty of options. We are going to use this time added options. Let's take a look on it. Yeah, definitely. So we've got here add security groups that will create the groups we would like to have for us. Like, so it's just as simple as it is. Uh, add security. It's not a tab allowed. Security grow group. Okay. Oh my, it's so convoluted. I don't like typing here. But I like PowerShell. So anyway, okay. We hit enter and we've got command complete successfully. So in fact, our groups are created. So let's think about it once more. If we are going to come back here to the server manager, we have groups already created. We have server an active directory authorized already also. So we would expecting that the exclamation mark is lost here, but no way. It's still here. So it's a pretty strange thing that this exclamation mark persists here. Even thought we have this groups configured. We have this directory authorized. So how to get rid of this in such circumstances when we are handled all of those a different way? So it's also possible. It's possible by using registry, because all of those settings are of course sitting in a registry. So let's go with the command prompt here and regedit. Okay, so what branch we are going to use is a local machine here. uh, we have a software class and we've got here a Microsoft. And because we're talking about the server manager, not the DHCP actually, because it's server manager which is responsible for monitoring all of those stuff, all of those roles and features and so on. So we are going to find our server manager here. Let's go down below. Yep, it's here, and roles. And what's the most scary here is that these roles are numbered. Yeah, these are the numbers, not a name. So it took me a while to recognize all of those, and you can obviously find something here, this NPS role, and so on. But we are interested in number 12. Yeah, number 12. Just remember it. And we have here what we have here, DHCP server. So uh, one level above we have a configuration state which is 1 right now, which means that it's not configured. Well, it's not true because actually we've already configured this, so let's forcibly tell him that it's configured. Okay, so we have to now close this and reload the server manager, and I hope that it will be working. Yes, definitely. It's working. So it's one of the ways to get rid of this if we are sure that we've done all of those stuff previously. Okay, so now we have this feature installed. We've got a post configuration deployed. So let's start with some basic stuff with some basic steps about the configuring the DHCP. All right, so it doesn't really matter which server we are going to pick, because as I told you on the beginning of this training, all of those servers are a part of a one broadcast domain or in one local area network. So from the client perspective, it doesn't really matter. The client will get through the whole DORA process by at first if it doesn't know any service. Of course, it uses the broadcast message, and it will reach all of those servers. So we can create a scope on any server, and it should be working. So let's pick the third one also. At first, I would like to show you some in a DHCP MMC snap and some things that are related to the DHCP itself before we'll go to the scope creation. So on the server level, I mean on a DHCP service level most, we've got to manage authorized servers here. So we can do a server authorization by this window, of course. Export list is a normal thing to export this to the text file or content of this level of the MMC snapping. So if you are going to take a look on it here, yeah, we've got here content of only one level below, so only this one. If we are going to use the same option over here, of course we'll have to get some scopes over here. So uh, it's not possible now, but of course if we were going to create some scopes, it will be. Uh, you'll be able to expose some scopes to the file. So it's quite handy if you are going to report something. Okay. Okay, so we got a views here that you can customize, add, remove columns, so common stuff. Nothing here. Important thing is that you can add more servers to the MMC snapping, which is of course quite commonly used in a bigger environment where we are dealing with a lot of servers, and if all of those servers have permission to each other, for example, if they're a part of one domain or one Kerberos domain, they will be allowed. You will be allowed to add more servers here. So we've got this one server, but we can of course add any other authorized here. Of course, I didn't authorize the rest, so you know. But even thought we can try to use it. Do K12, for example, 1, and clicking OK. Let's see if we actually are going to use it. Okay, it's not responding now. Let's give him more time. Yep, okay, definitely. We've got here, because it's not authorized, of course there are drop down red arrows, but we can of course then authorize it and add as many servers as we would like to, and just handle this from the one snapping, right? So it's quite handy because you can use a managing of the servers from one place. Okay, so let's you can of course delete it from the console only. So I'm sorry, damn it. Let's go back here again. So let's drop one level below. We have here option add or remove bindings, which means that you'll be able to forcibly tell him that you don't want him to listen on some particular interfaces. If the server has many interfaces, and for example one interface is used for backup only, and you don't really want to serve the services on this interface, you can add remove bindings and just unclick it, right? So we've got here only one interface, so we'll definitely would like to listen on it, right? Okay, so let's go further. You can unauthorize the server from this level, which definitely not is the best idea right now. You can do the backup or restore, which we'll be talking about later, because these are the parts of the bigger topic. Backup and restore are quite important topics, and we're gonna cover this later. So all tasks to just restart the service, stop or pause the service. View, we've been talking this already. Delete the server from the list. Of course, we are not going to delete the server definitely, because this is a role, so you already know that you have removed it in a different way. So don't be afraid to use it if you have already a lot of servers on the list. Some of these servers are already decommissioned, for example, and they're still on the list. You can just use to delete it, right? Okay, let's go to properties here. Oh my, not this one this time. Okay, proper. Yeah, it was this place. Okay, it was actually this place. This is a database path. Normally, the old database is like on the Windows System 32 DHCP folder. I just wanted to browse it, so maybe let's go with a different way because I would like to show you the structure also. It's quite important here to know the structure of the DHCP. So if we're going here and take a look, uh, we've got here a logs. These are an audit logs for the server. Uh, as you take a look on this, we have different servers for IPv4 and IPv6 logs, and the logs are divided into each day, right? So we get a Friday, Monday, Saturday, so on. So for every day, we will have a logs separately. We've got here the main database over here, and we've got a backup database. In a backup, there's configuration and database, of course, here, and this is normally done in 1 hour interval. So every hour, the DHCP server will be doing a backup to this folder, right? So if anything goes wrong and the database became corrupted, it can use the backup from last hour, and that's quite good. And of course, you can change this behavior. I mean, change a time interval uh, by using registry because it's also sitting there, and by using, of course, NetSH also, right? So uh, these two things you can change. I'm gonna show you this because it's not very commonly covered by the training materials. It's also quite convoluted. So okay, let's take a look on it. Well, I don't expect that you will have a lot of opportunities to actually configure this particular configuration parameters because it's not very often by the default they are set and they are used in the most of the environments I've ever seen with the default values. So, but anyway, you have to be aware that you are able to configure this. So at first, maybe let's check this on the side of the registry. So let's go to the, oh my god, regedit. Alright, my keyboard is regedit. Outstanding. Alright, so let's go with a local machine. It should be somewhere. System control set maybe on these are services, and we should look for our DHCP server. Okay, and the parameters. Okay, so there are quite of a lot of parameters that you can actually set. Some of them are also you will be able also to set by the GUI, like backup database path. This was the thing that I showed you a moment ago. This is the backup interval I've been talking about. This is 60 minutes normally. So if you want, you can change this behavior. This is a cleanup interval also for the database. So how often the database will perform some checking and some cleaning on the database file of the DHCP. Uh, what more? Of course, you can alter the database name, database path. This will be also a log file path. Anything you could possibly want to change. This one is quite important to know. I've also showed you here that we've got the log files here. Uh, these log files are located under the system. Let's go under this Windows System 32, okay, and DHCP, okay, and these are the audit log files here. Um, Actually, I've already faced the situation that in one moment when there is over 100 scopes on the one server, uh, the log was completely full, and in the log file, I found out that there is a message like audit log paused. Okay, I was a little bit scared at first. I thought that somebody paused the log, but no way. This is the value was responsible for this. So 70 megabytes per all week, which means that 10 megabytes per one file, right? So uh, you can imagine that every one of this file for IPv4 can be large up to 10 megabytes. It's hard for you to imagine, but believe me, it's possible in very big environments. So uh, If you would like to extend this value, you can of course do it, but for all files, right? So we've got 7 files over there, so you can, for example, use the different decimal value from 70 megabytes to 700 megabytes. Of course, it's not really a thing you should do. Uh, you should change this value accordingly to your environment. So only the files should be only as big as you need them to be, right? So mostly you'd rather use something in a very big environment like this, right? So 350 megabytes per all, which means that it's 50 megabytes per file, right? So every of this file will be able to reach 50 megabytes, and after reaching this value, you will see in the audit log, and on the end, of course, that audit log was passed. Okay. Okay, there is a lot of very important information that you can actually use from this file in the troubleshooting. Everything is explained here on the beginning. The logs are the first is an ID. Of course, there's a header over here, so you can just use it to try to decrypt those entries, right? And this is a legend here. So maybe we will go back to this when actually we will create some scope, and there will be some other entries and cleaning database interval and so on, right? So these are only informational things, and there are nothing about leases because there should be a information about assigning a lease, renewal, or something like this, right? So we're going to get back here. Okay, let's go back to our registry. We've got some things like restore flag. Restore flag, if you are going to use it ever or set it, or any program or a helper will set the restore flag to 1, the DHCP service will be no longer looking for the database file in the path, but it will try to use a backup database, right? So from this path, he will try to load it. So when the service is badly wounded and it's unable to start fresh from the normal file, he can set up the flag and use the backup file, right? So it's how it's working. Okay, but I told you that it's not the only place we can actually look for some very specific options. So now I'd like to show you also NetSH. Okay, so well, NetSH is a very powerful command that I've proved already, and there's a lot of options over here, so you can easily be overrun by those options. So let's go NetSH. Okay, it's easier to type because it's shorter. Yeah, well, so let's go to the DHCP options. Yeah, and here we have, well, yeah, we have to also pick the server. If you are not to type anything except server, it will take a local one, just like you would type a local host, right? So it's almost the same. Well, it's IP address. Okay, so we've got here show and set options. These two options, I mean, these two things that we can do actually. So by the set or by the show command, we can achieve a goal the same that in the registry, right? So let's go with the show at first. Let's go show and a question mark. As you can see, a lot of things, but we are interested in DB properties. So let's go with show DB properties. Yeah. Okay, I've already tuned this up before, so you can see here that there is database cleanup interval 30 minutes. Normally, by the default, it's 60 minutes, just like database backup interval. But uh, and now we are going to go back to the default values with that. So now we're gonna use set options. So from the server level also, we're gonna set some, as you can see, database backup path, database backup interval, database cleanup interval. It's very easy, right? You just need to be aware that these options are exist and they are tunable, right? So let's go with a set database or database. What was that? Database cleanup interval. Okay, database cleanup interval. And we are going to pass option 60, right? So if you are not type anything, you will be delivered some examples, some parameters, which are quite useful in many situations. But this time we are going to get back to the default value 60. So Let's go again once more with the show DB properties. Yeah, 60 minutes. Now, I need to say that you will not probably use this tuning very often because most of the environments use the default values, and they are using the default values because not just because they are not aware that they exist, but the default values are quite well. So 60 minutes is not a long time or it's not too short. So it's just tailored as it should be. And on the other hand, in the most environments, we are trying to achieve a situation in which in every server we've got the same configuration, right? So uh, it's better to get with the default, except the situation that you definitely and explicitly you want to use something different. Okay, so let's go back to the actually to the basic stuff because I told you that we will be talking about the basic stuff and we are going to a little bit too deep right now. Okay, so let's go back to the configuration of our DHCP. Okay, the last time we've been talking about the server level options here. So I've told you also where to you can tune up also these things, and let's cover now also the scope of the IPv4 server level, right? So let's go here and right click. What we do have here, we've got a statistics here, right? So um, the server are collecting some very important statistic from the perspective of the DORA, which is an acronym of the DHCP uh, discover, offer, request, acknowledge process. There are a lot of things here, right? So we've got a discover, offers, request, and acknowledge, but also next, which is not acknowledge, which means that the server is denying something. Decline is from the client side, right? So client decline is to use the lease and some delays we've got here, releases, and so on. A lot of interesting statistic, especially that one, total IP addresses in every scope, addresses in use, and so on. So you can use those for collecting statistic. You can create a new scope, new multicast scope also. Multicast as transmission one to many, right? So it's or many to one. Many to one, like one to many is broadcast. No, it's a multicast also. Okay, so it's also multicast, but defined for the IP address, multicast address. Okay, so that's the difference. Uh, Configuring failover here. So we're going to cover those things on the second chapter. And the user classes and vendor classes we're going also to cover in the second chapter because I would like to relate this to compare this to with options 43, option 60, and many important options that are used to set the devices like IP phones and Cisco access points and so on. Okay, reconciling all scopes, which means that you can verify and compare information from the database and from the registry, right? So if these are consistent, um, their view, nothing really, and the properties, these are quite important things. So how often update the statistics here? Do we enable audit logging here? Okay, show the boot p table folder also. DNS, it's quite important because the DHCP allows us also to automatically, dynamically update the and PTR records in the DNS service by using plenty of mechanism, including a name protection, uh, which also I would like to cover later because it can be also a lot of situations that are complicated, complex, and making many troubles here. Okay, so we've got the filters here. I'm going to also show you the filters today and in this chapter this time. More a failover overview. So if we're going some failover relationship with other DNS, DHCP, I mean service, they will be exposed over here. And advanced conflict detection attempts. So before DHCP server will assign any IP address to the client, it can use a simple ECMP to check if this if this host is occupied, if IP address is occupied and is not responding, right? So if we're going to use our detect conflict attempts, for example, on one, it will try before assigning an IP address to ping this IP address if actually is free. If it's not, it will mark it as a bad address, right? So you will see in a lease table bad address. So if you ever see the bad address, which means that somebody set this IP address statically and manually on the machine from the on the range that should be allowed with the DHCP, right? Okay. Server connection bindings I already told you on the level above here. Audit log file path, also where the log files are stored, also showed you this before, and something which is called DNS dynamic update registration credentials, right? So these are credentials of the user that is able to update the DNS. So for example, DNS admin. Why to use it? Well, normally when we're using the DNS, we are enabling DNS dynamic updates, right? Only if requested by the client and only if the server or on the client is capable to update it, right? But sometimes if we were, for example, talking about the older clients like here that do not request an update, and for example, we will set it here, so anytime when the client will get the IP address, we would like it also to update the DNS records, even if it's not we're requesting this, which means that it might be, for example, a Linux-based server. That means that this Linux, for example, base server will not have proper credentials, probably, right? So the server must use its own embedded credential to update this. I mean, the DHCP service must use its own credentials to update this record for this alien machine in the DNS, and that's why it will be using a credential from this one. So not the credentials of the actual client, but its own credential to do it on behalf of the client, right? In this time. So let's go back with the default values here, or just cancel. Okay, so this was a quick overview on the properties of the DHCP server with very short explanation of anything. So now I would like to show you also how to create actual working DHCP, and we are going to check this on the client side, right? So okay, so let's go back here and go ahead. We are going to create a new scope. Okay, let's name it somehow. For example, first I can name it my office LAN. Okay, so anything actual that will be okay. Uh, and IP address here. Okay, so we're going to use 192.168.0.1. It will be a first address that will be assigned. 192.168.0. For example, 50. Okay, so first 50 addresses of this network, because it will be 24 bits network, so which means that it was 254 IP addresses here, and only first 50 will be a pool to use to distribute, right? And these are the exclusion range. We don't need it, but I will show you also in a moment how to use it. Subnet delay, if we would like to explicitly configure some delay of the IP address assigning, how long the lease will be on the client. This is quite important thing to understand how it's working. Uh, These doesn't actually means that the, the client will be binded to this one lease one day, for example, right? Because there are two timers over here in the process. I'm going to cover this a little in a moment, okay? Because now we are just setting this up. So let's go one day uh, with no additional options here. Okay, so we've got a scope. It's red arrow means that it's down. So this scope is down right now. So we will have to activate it. Okay, the scope is now activated. And what do we have actually? We got a here address pool, so from 1 to 50. So far, so good. No leases right now. No reservations right now. No scope options right now. No policies, of course. No server options right now. And all two filters for MAC addresses contact, they are down also. So completely simple configuration. So let's now take a look on the client side and to check if it's actually working. Okay, I'm now on the client side here. So we've got beautiful Windows 7 here. And let's go with the network here and take a look on what address has been configured actually. Let's go with the cmd ipconfig ipconfig. Okay, so actually we can see that this IP address, first one as we expected, has been deployed on the client. Let's go with ipconfig all to check the DHCP server, which should be somewhere here. Definitely should be somewhere here. DHCP server, okay, 192.168.0.53 because it's a third one. Okay, so we've got it here. Okay, so let's go back to our server right now. Third one. Let's go back to our DHCP console once more, and to check what we're gonna see here in our scope. Address leases. Yeah, well, this is our client. So we've got our client here, and what these icons also mean something. This, for example, this particular one means that he's trying to update his DNS record, but he's not yet succeed, right? So something, for example, our DNS configuration is not as good as we expect it to be, or just I have no DNS server here plugged into the environment. But it doesn't really matter here. The lease is now exposed. We've got it here, and the client got this on his side, right? So what we're gonna do is now perform some exclusion here. Okay, so we've got from this point. We're right clicking here on the address pool, for example, new exclusion range. Let's assume that we don't want it to use a first 10 IP addresses because we reserve those addresses for printers, for example, right? So first from 192, 168.0.10 from 1 to 10. Okay, so first 10 IP addresses are not going to be used. So now I expect, and possibly you too, that the client will be using 11 as a first available IP address. So let's go with that. Okay, let's go on a client. Let's go with ipconfig renew first. Okay, I don't like it, so release. He don't like it also. Okay, we've got nothing. And renew. Let's give him a, of course. Well, so we've got at least 11. Okay. So so we can exclude some addresses to, for example, if we don't want it to be used by the DHCP from the pool. Okay, but let's go back to our client. Let's change the scope properties. Oh my, scope change from 1 to 60. Okay, now you are going to see. Now you can. I suspect you can see if I'm going to refresh it that now this pool is also including our service, right? So we definitely in this situation need also exclusion range here for our service, right? Which addresses are from 51 to 53. These three IP addresses are used by the service, and we are definitely don't want them to be assigned to the client, because if we are going to assign this IP address to the client, there will be IP address duplication, right? Actually, uh, I can show you this here. Uh, so let's change this. Let's go back with the delete this exclusions. All right, and we are going to change properties here from 50 to 51, for example, to 60. Okay, and first IP address that it's going to be assigned to our client is 51, which is actually not really good situation because 51 IP address is also IP address of our running Active Directory controller. So let's go back. If actually uh, it's gonna give this IP address to the clients, let's check if we've got a set um, conflict detect attemptions here. Let's better do this because uh, we don't want to mess it. even more than it's already masked. So let's go now to the client. Let's go with the release and renew. And what we're gonna see is, okay, it's taking a little bit longer here. It's definitely have some problems. As you can see, he gave our machine 54. Why it doesn't get it 51? Because 51 was the first IP address of the pool, right? So actually he should give an IP address of 51. But as you can see, he marked those 3 IP addresses as the bad addresses because they find out that there's something under these IPs. These are our servers, right? So the DHCP server is not allowed to get to give this IP address. If we are not going to configure this conflict detection, attempting of a conflict detection, he will give an IP address to the client, but there will be a duplication, which is something we would like to definitely defend ourselves from, right? Okay, but we've messed something, we've definitely messed up, so let's go some little cleaning here, and we'll go back with a fresh environment in a moment. Okay, I got back. I recreated this scope, and we've got address pool from 1 to 50, and we got only one active lease, right? So I'd like to show you now how to deal with the DHCP options over here. So in fact, we've got the 3 levels of options that we can divide into 3 levels. So first is the level of server options. So which means that the options that we'll add here will be delivered to every scope on this server, right? Then we've got a scope options that will be delivered to all IP addresses or all devices in the scope, and that would acquire an IP address. And then we've got something that is mostly omitted in training materials. Also, we've got a reservation level, which means that we can uh, set some DHCP options per reservation, right? So let's try with creating some options over here. So we are on the server level right now. Let's go with, for example, domain. So option 15, DNS domain name. Let's name it Pulp-IT.pl. All right. So we've got a first one here, and this icon represents that we've got a server level here. Okay. So when we go now in the scope options, and we're going to refresh it. Yes, we've got something that was previously set on the server options, but we've got it in a scope option. It was inherited from level above, right? So if we create here something, for example, we have not yet configured a router, right? So every network, if you want to have a connectivity to external world in OSI level 3 layers, so which means that we need a gateway here. So let's assume that this is our gateway, okay? Yes, so we are going to deliver domain name and router for this devices that will be inside those scope. Okay, so we've got now one lease for our test PC. So let's create a reservation from it, which means that this PC will always have the same IP address because it will be reserved for this PC, this particular PC. Okay, so we can either create a reservation here, but as we have a reservation or a lease already assigned to the client, we need to go uh, add to reservations, right? So lease was successfully converted to reservation we've got, and in reservations we've got this PC. Okay, and now if we're going to right click over here and go to the configure options, we can create some additional options to the scope, reservation level, right? So let's go with the time server, for example, or no, DNS server. We'll deliver the DNS server here. And let's go to deliver him 192.168.0.50, even a 60. Okay, it's not existing DNS server, so it will try to check it. And of course, it will communicate that it's something wrong with this DNS server. I know that really good because it's not working. Nothing is under this IP address. But we want to still add it. So yes, we can forcibly add this DNS server and then add another one, this time proper one. It will be used as a second one or so. If the first will be not responding, the second one will be used, right? Okay, and these DNS server options we add to the level of the reservation. So if we'll go now to our test PC and we'll refresh the lease, we'll renew the IP addresses, we should acquire all of those DNS DHCP options. Okay, so let's go here, over here. All right, need to log in. Got it. Let's give him a sec because after a restart of VM. Alright, so I suspect that he's already got whatever he need to have. Let's go with the change adapter settings. Oh, it's not very good, but let's check it anyway. Okay, he got a proper IP address. He got a proper DHCP server. Okay, but I have no DNS options yet. Let's if we're disabled and enable it, it should work like a renewal. All right, now it's pretty good because I can see that it's a part of a domain right now, so it seems that the network adapter is okay right now. And yes, definitely we've got here a DNS option, 60 not an existing DNS, 51 existing one, and okay, we've got a domain connection specific DNS suffix, Pulp-IT. So in fact, he acquired all of those options that we expect him to acquire. Okay, so that's how it's working, right? So don't forget about this third level of the reservation level, right? Because it's very useful for example, in a test environment, if we're testing some new settings. So and we've got a one PC only. We don't want to mess with the whole environment and the whole scope, which can have hundreds of IPs already present. So we can prepare some reservation for our test PC and just change an option for this particular one unit, right? So it's quite good. All right, so the other thing I'd like to show you will be filters. Filters are, of course, over here, some sort of a specific explicitly denying or allowing MAC addresses because it's based on the MAC addresses. But inside those filters, as you can see, there are drop down arrows here. So both of the filters are disabled right now. You can allow one filter, enable one filter or another. You can, of course, also enable both filters. Then denying will have explicitly will win over the allow, right? So he will have a precedence over the allow. So but in some environments, some of the monitoring tools will raise an incident on this and will tell you that it's improper configuration because they shouldn't be used both allowed and deny filters. Well, they could be, but definitely it's better and a more clear environment with only one filter allowed. So enabled, I mean. Okay. So let's go with the filters. Probably let's go with our lease here, so which was converted to reservation already. Let's take a look on our user unique ID, which is a MAC address, in fact. Um, the first three hexteds, so 0015 5D, these are normally vendor identifiers, right? So for example, Hewlett Packard has his own ID over here, so or Cisco or something, Cisco phone, for example, or something like this. You can use this knowledge and, for example, prepare filters for particular vendor devices or something like this using a wildcards, right? Because here inside the filters, you'll be allowed to use wildcards. For example, let's deny this machine of using this DHCP server, right? So we're going to enable deny filter, right? So let's go ahead with this. So we've now enabled deny filter, and then inside the deny, we would prepare the new filter for this machine, right? So Uh, let's check if actually it will be working. Let's go with the export list maybe, because I'm pretty sure that I won't be able to copy and paste it directly. So let's go here. Let's go with this one. Okay, this is a reservation. We've got our ID here. Now I can copy it. Yep. And then we can prepare and we can try to prepare some deny filter over here. So new filter. We are pasting this MAC address without any hyphens, without any dots. It's just a pretty simple MAC address, right? You can use that. You can use that one, or you can use the wildcards over here. So let's go here with the wildcard. Some description like, I don't know, maybe that's our uh, forbidden device. Okay, let's add it. It will automatically convert it to hyphens format, and you can see it should explicitly deny any device that MAC address will start with with the letters and digits, right? So let's try it. Let's go to the client, client here. Okay, let's go simple renew. Oh my, I forget. CMD. Okay, ipconfig release. Nope. A. Oh god damn it! What the hell is wrong with my keyboard or my hands? All right, we have no address right now, so let's go with the renew. Bomb. And let's wait and let's look what will happen. Well, if we are right, it shouldn't acquire any IP address, so you should use APIPA, so automatic private IP address from the Microsoft pool dedicated for this. So let's wait and check. Okay, I had to speed up a little bit this process because you won't believe, but I was waiting for about 2 or 3 minutes for just this message that was an error and was unable to contact our DHCP server. So it worked as we expected, right? So if you're type IP configure, yes, we've got 169.250 for 16 beats, 60 beats, 16 beats, I mean. Sorry, and we have a PIPA address. So he was unable to contact the DHCP server and acquire proper IP address because of this filter, right? So it seems that it's working properly. So remember also about the filters, they're quite useful. For example, if we have two servers that deploying the same leads for the devices, they're part of the same broadcast domain, which means that they both be contacted, but we want only, for example, one of those server assign IP address for phones, for example, like for Cisco phones. So we can use this first 6 digits from the MAC address and the wildcard to forcibly deny or forcibly allow to these devices to contact our server, right? So this is quite important to know. One of the last things I'd like to present you, and I've already mentioned this in a moment before, is a DORA process. So I know that it should be a part of the beginning of the training materials, and normally it is. Well, they're all starting from the theory, and then they're going to the practice in laboratories. But I'd rather like to show it first, and they'll try to explain this, why this behavior is like this, or you know. So let's talk about the DORA. Well, DORA is a discover of request acknowledge acronym for the DHCP, and it shows the basic steps that must be taken to make the communication in the DHCP process between the client and the server, right? So uh, I found out that there is quite a good materials in the TCP guide here, so I will try to use it to explain. So let's take a look on this picture and this drawing. Well, at first the client creates something which is called this DHCP discover, and he's going to send this message on the broadcast MAC address to reach every machine in the broadcast domain. So, which also means that it will reach every DHCP server that is capable to listen under the UDP 67 port, right? Because it's a port when the DHCP server service is listening. Okay, so the server is going to, well, take this message, the DHCP discover message, and create some offer. And this is also the moment when the server tries to ECMP ping if this IP address that he's going to offer to the client is proper, right? And it's not used already. So he picked some IP address and some basic options for the connectivity, and then he sends it with a DHCP offer message. Yeah, so it's the second step of the DORA process. And every server capable inside the broadcast domain of performing some offers is going to offer this to the client. So okay, the client collects all of those stuff and he prepares something which is called DHCP request. And request this time, of course, we need to mention that the second step, so the sending an offer from the server to the client is done by the unicast layer 2, right? So the server already know who actually asked for this, so he can contact it directly, right? So no need to use a broadcast anymore here. But on the third steps, when the client decide which of the offer he would like to pick and preparing the DHCP request that will be sent to the client uses broadcast once more. He uses a broadcast because he must inform any other server that they were not picked, right? So he requesting a particular for a particular IP address, but he's doing it by the broadcast to make a notice for every server, right? That he's doing this. And then the server who was actually offered at first, he's going to do some additional checks, of course, and prepare something which is called DHCP Acknowledge message, right? So the final acknowledge arrives to the client, and the client probe also offered the IP address, and this is which is called a bounding, right? So the lease time is starting, the lease is acquired by the client, and this is how the DORA process looks like, right? So the IP address is already on the client, and then we've got a lease time for it doesn't really matter, it can be 1 day or so on, but when the lease time starts, there are two timers that are tightly bound to the lease time. This T1 timer and T2 timer, right? So T1 timer is called a renewal time, and it's a half of the lease, so 50% of the lease time. And let's skip to the other picture, also from the same side. So let's go on. We've got a client who already has an IP address acquired by the DORA, full DORA process already, right? And when the T1 timer will be hit, then the client, using the unicast, asks the server by the request. So in the 50% of the time, the client is going to ask the server by the unicast with the request message to renew the IP address. So it won't wait till all of the time will be end. So 1 day will last and wait to the very end moment and then get the lease. No, he will try to renew the lease on 50% of the time, right? And when something goes wrong and he will not get an acknowledge, so this is something which is called short DORA. It's not going discover anymore because he already know what is the IP address of the DHCP server because he already obtained an IP address from this. And the client has already an IP address, so no need to do discover and an offer. He can do just request, and if the server will accept this renewal, there will be only acknowledge. So this will be a short DORA. But if anything goes wrong and the server won't answer for this request, then the second timer is also inbound, right? So about 89% or something about this. It's a T2 timer, right? So it's a rebinding. When the 2 timer is hit, then the client no longer try to reach the DHCP server by the unicast. So no longer tries to contact the last known DHCP server, but he's trying to contact all of those servers. So he's sending the same short DORA message, but on the broadcast. So every server, DHCP server capable to extend his lease will be asked for this. And then if anything goes wrong in this point, then if 100% of the lease will be reached, then the lease must be dropped and the client machine is starting all over again with the whole DORA process. And that is how it looks like the short DORA. Okay, anyway, it's quite important to know how the device and the server interact between each other. It's very important in troubleshooting steps. So it's quite good to remember this or to know where to find it. There is a lot of drawing, a lot of pictures over there, so you can get it deeply, get known deeply. So no problem with that. Okay, that's all about the DORA process. Okay, so that's all about the basics, right? So we have configured some scope. I showed you several options of the DHCP server. They're pretty easy. I showed you how does actually it's working. So and I proved also that the client acquires some proper IP address. How about the filters? Some word about the server options. Of course, it's upon you entirely to browse through all the server options, for example, because there is a lot of them, and not every option is covered over here. So sometimes we need to manually add some options over here. This is also very important. For example, for Pixie boot devices, there is no option 60, for example, right? Because if we are going to scroll here, you can see that there is a gap between of those options. So, for example, option 60 Pixie client is not existing anymore. So, you have to browse for all of those options and try to look to the RFC documentation to check what the hell they can mean. But about adding additional options over here, it's possible from this level, right? So you can set predefined options. This is the thing that is responsible for adding an option. So we're going to use standard options here, and you would like to add a new option, right? So for example, we've got a Pixie client option, which will be code 60, right? And with no default value, right? So now, if we're going to click OK on that server, we will be able to use this option here. So if we will go, for example, to our scope, to a reservation, and we will try to configure some options for reservation. In this list, we should have there should be a option 60 present, right? So and in fact it is. So we can use here option 60. Of course, it shouldn't be byte because it should be also Pixie client value. So in fact it was a little mistake. But anyway, this is the way how can you create some additional options, right? For if for example some device may require it, right? For example, 242 is option required for the Avaya phones and so on. It's a lot of devices require a lot of different options, right? So you can use it just like this. Okay, I hope that you enjoyed this training video. This was a basic. So as I promised, the next video will be about much more complicated stuff with explaining some additional options, with explaining vendor classes and so on, failovering, backupping. Well, we'll just dig a little bit deeper. So thank you very much, and I hope you enjoy.